Hello, everyone. So let's continue with our course of building retrieve agents on Databricks. So now I'm going to talk about parsing and chunking. Okay, what they are saying here is that the effectiveness depends of the quality of the data that it retrieves. Makes sense. Okay, so before embedding generation, raw unstructured data must be ingested, stored, and transformed that LLM can interpret. Okay, and they talk about here a native Databricks function, AI parse document, and some strategy of text chunky. Okay, so yeah, uh, as expected, everything should be on unit catalog volumes. Okay, by storing raw volumes and then process min data. Okay, so yeah, everything should be here processed, the PDFs, the images, and then should go to be chunked. Could be a fixed size or a semantic one. And then we have several chunks, and then we are going to embed it, and then we are going to store on the vector store. Okay. Okay, so document can be used by AI parse document, enables robust parsing of PDF and extracting structured contents. Right. So real world has multiple problems as expected. So can be images, multi-column tables, correct? Okay. And properly structuring this while maintaining semantic. Okay. We should maintain hierarchy information, order, conceptual. Exactly. Flow, we have multi-columns, so we have header, we have images, we have tables that should be connected to this. We have page numbers that should be also disclaimed, should be take off. Yeah, okay. So to address this challenge, modern approaches leverage LLMs and OCR models. Unlike traditional text parser, this model can see the document layout. Cool. Okay, can identify text within images while can interpret spatial arrangement of the elements. Okay, so we can use the AI parse document, okay, that exists on Databricks, and the AI parse document is the leading Databricks tool for this task. It invokes state-of-art generative AI model to extract content for unstructured like PDF and images and returns a JSON. Oh, cool. So this is the schema and it's a several simple SQL. Very cool. So talking about data cleaning and transformation after we do the parsing, probably we'll get lots of garbage such as the page numbers and headers and all this that we don't need. So yes, we need to, before text can be chunked, it requires cleaning to remove artifacts that degrade the quality. So raw content structure often includes headers, footers, page numbers that interrupt the semantic flow of the text. Okay, cleaning logic should be applied to the output. Original work, seed formatting text can confuse it. AI parse document can understand the format. Cool. So also it's also important to provide, let's see if it is, and it's rely on metadata to filter the data. Yeah, should provide metadata to filter before sending during extraction, extracting associated matter such as document titles, authors. Okay, it's great. It's not the file properties. Functions like AI extract can be used to identify and pull structured fields. Invoice date, contract type. Cool. Okay, let's talk about chunky strategies. Chunky is the process of dividing long documents into smaller, manageable segments. Makes sense. This step is essential because embedded models have context window limits and retrieve precise information. Another important consideration is the relation between the context size and the language model. Not in the middle, that occurs on the LLMs. very deep within large context models. Yeah, of course. As a result, creating smaller annual events is preferred to ensure. Okay, yeah, but smaller chunks, yeah, is more expensive probably. So we can have fixed size and recursive chunky. So fixed size chunky, okay, that divides based on a hard card or token count. Yeah, see here, always the same. Semantic, one that is chunked by sentences or by paragraphs. Okay, this is the more recommended one. Advanced chunky strategies, it's overlapping, okay, that will overlap the other chunk by 10-20%. What is this for? By repeating the small portion of tests at the beginning of the next chunk, ensures that no context is lost between them, preventing sentence or ideas from being cut off. Ah, yeah, okay. So just imagine that this phrase makes sense related with this one if we cut, okay. Embedded based semantics chunks. This one is a more advanced method that is use a embedding model to determine breakpoints. It calculates the semantic similarity, pardon, between sequential sentences and only breaks the chunk when the topic significantly change. Okay, this ensures that each chunk represents a distinct and coherent. Okay, it breaks making based on the topic. Okay, a Windows summarization. This is a context enrichment method where each chunk includes a Windows summary of the previous few chunks. Instead of just seeing the current text, the model receives a summary of what came before. Ah, cool. Providing broader context with that. Okay, this is a summary of this one. This is a summary of this one. Okay. So while embedded models are covering detail in the way, okay, this is going to be called later on, but okay, we should be aware of the context in the limit. Every embedded model has a maximum token limit. If a text chunk exceeds this limit, this model will simply truncate the text. Okay, ignoring beyond the limits. Yeah. So if we are go more than the expected, it can go here and it doesn't make sense. So lost data. Therefore, the maximum chance must always be safely below the embedded model context limit. Also the granularity, so large versus small chunks. Let's see, a larger context window allows for bigger chunks capturing more context, but potentially diluting specific details. Okay, smaller for smaller chunks, or window smaller chunks, more, but may lack of surrounded context. Yeah, exactly. The choice often is directed straight off that must align with the capabilities of the specific embedding model you intend to use downstream. Some tools that we have on Databricks. Documents processing on Databricks combines native AI functions with leading open sources libraries such as LangChain to create multi-step pipeline. This workflow transforms raw files into embedded texts through sequential parsing and chunking. Okay. For the parsing, we have the AI parse documents. That's the one that we talked about it. It's commented. It returns structure. So it's a JSON actually. By chunky, after exact, the test must be divided into smaller emergent chunks. So we have LangChain, or we can use custom functions. LangChain libraries like LangChain provides advanced splitting logic. Cool. For parser tests, LangChain suites context splits, supported diverse format inside, making the industry standard for string. But we also have some custom developers may also implement custom Python user defined functions, UDFs, to apply splitting logic, such as divided by the specific markdown headers. Yeah. Okay. So The key takes is unify governance, store raw files in unit code, process its chunks in data tables to maintain full data lineage and security. Sequential processing document is a two-step. Use AI parse documents for robust extraction, and second, use libraries like LangChain for the chunk to cut. And then we also have advanced chunking like semantic strategy, overlapping, and so on. Okay. And I think I got it about this, and I hope you understood as well what we had here. Thank you. See you next